Now let's proceed to vector component. Suppose that we have a car here that started from this point and traveled to reach this point. So vector R represents the straight line that the car has traveled. So according to this direction, the car traveled northeast. However, the car can also reach the same finishing point if the car traveled first due east and then due north. So um, this these arrows here represent the alternative path. So this is also the components of the vector r. So this vector here is the x component of the vector r. So the x component of the vector r is parallel to the x-axis, and same for the y component of vector r, it is parallel to the y-axis. So the components x and y is always perpendicular to each other. So if we add this to vectorially, we will arrive with vector r. Now let's try to solve example problem 1.4. So So a displacement vector r has a magnitude of 175 meters and points at an angle of 50 degrees relative to the x-axis. So find the x and y components of this vector. So this would be the figure. This is vector r, this is the x-axis, and this is the y-axis. And the angle of the vector relative to the x-axis is equal to 50 degrees. So again, we have the magnitude of the vector r that is equal to 175. So let us write first. So r is equal to 175 meters. So first, let us find the x component, the magnitude of the x component. So since the x and y components are perpendicular with each other, we can form a right triangle here and then use the trigonometric functions to solve for each component. So let us solve for the magnitude of the x component of the vector. So this is, since this is the adjacent side and this is the opposite side, x is equal to 175 meters times the cosine of the angle here, that is 50 degrees. So this is equal to 112.49 meters. So the x component of the vector, that is 112.49 meters due east. And while for the y component, so since the y component is opposite to the angle, we will use the sine function. So we have first the hypotenuse, which is also 175 meters, times sine 50 degrees. So y is equal to 175 times sine 50, that is equal to 134.8 meters. So for the y component of the vector, we have 134.06 meters due north. So we now have the x and y components of the vector. So we can also check this one. So since this is a right triangle, we can use the Pythagorean theorem to check if these two magnitudes here will result to this magnitude here. So this should be the square root of 112.49 squared plus the 134.06 squared. So this is equal to 175 meters. So this is correct. So let's solve practice problem 1.5. A displacement vector is 23 kilometers in length and directed 65 degrees south of east. What are the components of this vector? First, let us label this as the north, south, east, and west. So for the vector, let's assume that this is the displacement vector. And since it is directed south of east, dito tayo sa east magre-reference. So, this is 65 degrees. And the magnitude of the vector is equal to 23 kilometers. So we are asked for its component. So for the x component, we will use the cosine function. So cosine 65 degrees is equal to the x component all over the hypotenuse, which is 23 kilometers. So x is equal to 23 times cosine 65. That is 9.72 kilometers. So this is 9.72 kilometers due east. While for the y component, so this is the y component parallel to the north and south line. So this is opposite with respect to the 65-degree angle. So, we'll use the sine function. So, sine 65 degrees is equal to y over 23 kilometers. So, y is equal to 20.85 kilometers. And the y component is equal to 20.85 kilometers due south. Lang natin. So, these are the final answers. Lastly, let's have a recap. We have two notes here. For a vector to be zero, every vector component must be individually zero. That means if this vector here is equal to 0 and the y component of the vector has a value, the vector is not equal to 0. And vice versa. So, the same. But, for the vector to be 0, the x and y components should be both equal to 0. So, for the next one, two vectors are equal if and only if they have the same magnitude and direction.